The Orion Nebula, also known as Messier 42, M42, or NGC 1976. It is a diffuse nebula situated in the Milky Way, being south of Orion's belt in the constellation of Orion. It is one of the brightest nebulae and visible to the naked eye in the night sky. M42 is located at a distance of 1.344 plus 20 light years and is the closest region of massive star formation to Earth.
Major find, the Orion Nebula, the great Nebula of Orion. I found it, and I found a lot of other nebulas and star clusters. Amazing deep space photos. We're going to go right into the constellation, right up to the stars. I also found the star Rigel in the same photograph as the giant nebula that I got. Each country will see the nebula a different color. In the northern hemisphere over here, I got it a greenish turquoise, amazing dreamy color. Wait till you see it. Now this, what's the most interesting about it, it fascinates me. This is a stellar nursery. This is where stars are born. Stars grow, and they don't know how they're formed. They're formed inside of these nebulas. This Orion Nebula is not one item. It's one item, they called it the nebula, but inside of it there are all these clusters, star clusters. There's approximately 700 stars in formation inside of this cluster, of these clusters. And there are all, recently they discovered, the Hubble telescope also discovered protoplanetary disks inside, about 150 of them, in the nebulas. And they hold about, the 150 nebulas, they hold about, they call them proplyds or proplyds, are stars that are being born. Now listen, these stars are at their earliest form of evolution. They're being born. It's the first beginning of the solar system. They're at their first stages at the beginning of the solar system. They're being born. And these stars are very different to one another. There are so many different kinds of stars. I mean, this video would have to take 4 hours to explain just about this nebula. There's so much information. I'll make more videos about it. But we're going to go see it up close. And upcoming videos, I also have over here the Witch Head Nebula that I got with all the indications. Now, all these points that you see on this page right here are the stars that I've gotten. Now, we'll go see each and every one of these during the year, during the months coming, in detail. And another amazing star we're going to go see is the one I got, as I said before, Rigel. Right here, dead center. The cluster we're going to go see is over here. This is the great Nebula of Orion. And we're going to go see up close, I'm going to show you the birthing stars, the protoplanetary disks, where the stars are being born. There's 700 of them. So we're going to go see this in detail, and we're going to go see the star Rigel.
We are looking at the section of the formation of stars that are exiting the nebulas at over IC 420, NGC 1981, 75, 76, 77, NGC 1924 at the back, higher part of the nebula. And we are seeing the birthing stars.
One Orion. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13. There you go. 13 areas that we're going to be looking at. Close detail. The great Nebula of Orion.
I am bringing you inside of the nebula. Look at the openings, the mountainous, heavy gases, condensed, the density of it, the weight of it, the mass proportional size of it. I hope this is a nice view for you all. The entirety of the Orion Nebula extends across a 1-degree region of the sky and includes neutral clouds of gas and dust, associations of stars, ionized volumes of gas, and reflection nebulae. The nebula is part of a much larger nebula that is known as the Orion Molecular Cloud Complex. The Orion Molecular Cloud Complex extends throughout the constellation of Orion and includes Barnard's Loop, the Horsehead Nebula M43, M78, and the Flame Nebula. Stars are forming throughout the entire cloud complex, but most of the young stars are concentrated in dense clusters like the one illuminating the Orion Nebula. Take a look at this. There's a lot of talk recently about Hubble telescope bringing us our first view of a star in formation inside of the nebula. Check it out. You've just seen probably how our planet Earth itself wound up into the solar system. I wonder how many stars this nebula can make in 7 days.
The stars, and what I mean by labeling is, first of all, learning about the stars, understanding them. It's a bit more complex than I thought. So at the same time as I am studying the stars, everything I learn I will make videos about interesting points, and that way I will be able to remember myself and go over the videos if ever I want to remember something. But these are the stars in the constellation of Lyra that I found, and in a beautiful snapshot that I posted in the video a couple days back. This double star here, spinning so quickly, emanating a light here. There's a bunch of important factors that you have to know first about understanding stars, and that's what I did not understand before. Like, for example, the different colors of sun. I say suns. They're suns. They're stars. Different colors of stars, oranges, red, but these are the sizes. This was just in the constellation of Lyra, all the different sizes. You have some binary star systems. They're a bit lower in the page. There's some trinary star systems. I'm trying to show all the characteristics of the stars, and through the year we'll be working on that too. I'll be showing more and more detail, trying to get the pictures better and better. But yeah, to get an idea of how it works about stars. Stars are classified from type A to type O. There are various types of stars. They're labeled from A to K. They have all letters. And they have variable temperatures from 3,000 degrees Fahrenheit all the way up to 100,000 degrees Fahrenheit. So when you look, it's interesting to know, because when you're looking inside of the constellation or at these pictures, you'll know by looking at the colors what temperature the surface has. To be able, each color of a star is the indication, always the perfect indication to know what temperature the surface has. Like the red, there's pinks, there's yellows, there's greens. It doesn't stop. It's never ending. And they're very beautiful, and they're so interesting to learn about. And another very interesting thing is that each star, you cannot tell the temperature by the size. It has to be the color, because some are bigger, some are more brighter, more light coming from them, a more luminosity from each of them, but they are not necessarily stronger. You could have a star twice as small that is a lot stronger than this one. For example, this one's stronger than this one. You could have a surface heat stronger here, as we can see here. This one is less heat, but it depends what it's where it is also in its stage in evolution. Some of these suns, stars that I got in the constellation of Lyra some of them are hundreds of thousands of times bigger than our natural sun here. This is what's hard to wrap your mind around. Say to yourself, like this one here, for example, I'm just giving you an example because I don't know exactly which star this is. This could be the size of our sun, what we would see from that distance, and this could be the size of a star that's out in the universe, and some are way bigger than this, I am sure. And of course, it always depends on the distance that they are at. That's why when you see a star, you can't really say, wow, it's a big star. You have to really localize it, locate it, in which constellation it is. But it's not hard. This is how I'm doing it. By doing this through my pictures, I'm able to find out how far out I am in space. It's not a lie. It's right there. I have the stars. I caught them. So if I'm able to look at 400 to 700 light years away from Earth, I can check every galaxy in the surrounding area over Earth, over my head, in the field of view of my camera. And these are deep field views. So now what I'm doing, you know that I always like zooming in, of course, so what the heck, why not give it a try? Inside of these constellation pictures, I was bringing out the small stars at the back, and you know what? A couple of them that are big enough, I am going to get some color. These stars, I have no idea how far they could be, but they can't be any closer than 400 light years away. So could we be looking at one from 4 to maybe 1,000 light years away? Like I said, a camera is only part of the work. You have to know how to operate a camera. You have to completely, entirely get off the auto function on your camera and use the manual functions and understand the aperture.
Now here's my question I've always asked myself. There's no wind in space. Oh, but there is, and there's a lot of it. Stellar wind and their effects have a major effect on the universe. Once these stars are formed within the nebula, emit a stream of charged particles known as a stellar wind. Massive stars and young stars have much stronger stellar winds than the sun. The wind forms shock waves of hydrodynamical instabilities when it encounters the gas in the nebula, which then shapes the gas clouds. The shock waves from stellar wind also play a large part in stellar formation by compacting the gas clouds, creating density and homogeneities that lead to gravitational collapses of the cloud. Wow.
Spectacular. I really want to zoom in to show you this part, because this is where we're seeing the birthing stars. NASA had a blurry photo too to get in from Hubble. I think this is the photo right here, guys. It was over the head here, I say. I call it the head with the eyes here. Someone looking back at you. That's absolutely incredible. I can see a nose, mustache, beard, and wow. Look at those colors I was able to get. The Orion Nebula. I've never seen anything so beautiful in my life.
So 13 hours later, all the calibrating, the photos, the time, the cold, the video, the studying, it paid off. I learned so much about the great Nebula of Orion. So please enjoy. The talking is finally done, and now enjoy the most amazing footage you'll ever see of the great Nebula of Orion.
Planets are alive. Imagine that. This is Rigel, and this is how close I was able to get the star Rigel. I'm not going to post a lot of information about it. I wanted to integrate this into the video, but don't worry about it. I'll get another video up for you guys in depth and detail about this. But now I'm too much into the nebula and I'm going off about stars. So this is Rigel. This is what she looks like. Ain't she beautiful? Look at the beautiful pinkish hue radiating. Always a beautiful cross. Across this way. It's also across this way. And you can see Rigel inside here. And the massive energy and power, the blue color flame that's around it.
Rigel's star, also designated as Beta Orionis. It is generally the 7th brightest star in the night sky and the brightest star in the constellation of Orion, though there are times where it is outshone in the constellation by the variable Betelgeuse.
Thousands of miles out, you can see on the bottom right here, Rigel's light emanating from where it is down here. Recognize these two? This is 0 Lyra and 1 Lyra in the same photo as the nebula. So in one photo, Rigel, Orion Nebula, 0 Lyra and 1 Lyra in the constellation of Lyra. So Lyra and Orion. Here's a massive pocket of stars that just came out. Close by, you can see it. Look at them all. Zero Lyra and Rigel, this massive star. Every corner there's lurking one of those red stars or objects. One here, there's one down here, right there. Where the eyes are. What is that? It's like a portal, a light portal.